Dear students, today's topic is in inverse trigonometric functions we are going to find the principal value branch of some type of functions. Before going to the topic, just will recapitulate what is the principal value branch of 6 inverse trigonometric functions and some of the properties of inverse trigonometric functions. The sine inverse x, its principal value branch is closed interval minus pi by 2 comma pi by 2. Cos inverse x, its principal value branch is closed interval 0 comma pi. Tan inverse x, its range or a principal value branch is open interval minus pi by 2 comma pi by 2. Cot inverse x, its principal value branch is open interval 0 comma pi. Then secant inverse x, its range or a principal value branch is closed interval 0 comma pi minus set containing pi by 2. We are going to exclude the angle pi by 2 in a secant inverse x. Last one is cosecant inverse x, its principal value branch is closed interval minus pi by 2 comma pi by 2 excluding minus set containing 0. Okay, these are the principal value branch of 6 inverse trigonometric functions. Next we'll move on to the properties of inverse trigonometric functions. Just I have listed some of the properties, students. Those properties I am going to use in a problems. First one is y is equal to sine of sine inverse x is equal to x. Students, sine inverse x is there, so obviously x belongs to closed interval minus 1 comma 1. Next, y is equal to sine inverse of sine x, x will be angle, so that x belongs to closed interval minus pi by 2 comma pi by 2. This is the principal value branch, isn't it? Then sine inverse of minus x, tan inverse of minus x and cosecant inverse of minus x. Here these three will be the one pair and these three will be the one pair, students. See, observe, sine inverse of minus x is equal to minus sine inverse x. X belongs to closed interval minus 1 comma 1. Tan inverse of minus x is equal to minus tan inverse x. X belongs to set of all real numbers. Cosecant inverse of minus x is equal to minus cosecant inverse x mod x greater than or equal to 1. Cos inverse of minus x can be written as, students, pi minus cos inverse of x. X belongs to closed interval minus 1 comma 1. Secant inverse of minus x is equal to pi minus secant inverse x, comma x belongs to mod x greater than or equal to 1. Cot inverse of minus x is equal to pi minus cot inverse of x. X belongs to R. Okay, please recall all the properties and we have proved these results also. Now we'll move on to the problems. That first problem says find the value of, or we can say that find the principal value of sine inverse of sine 2 pi by 3. Students, please observe here, sine inverse of sine 2 pi by 3 is there. According to the property, sine inverse of sine x is equal to x. X belongs to closed interval minus pi by 2 comma pi by 2 or not. Okay, please observe 2 pi by 3. Whether 2 pi by 3 belongs to closed interval minus pi by 2 comma pi by 2? No, does not belong to closed interval minus pi by 2 comma pi by 2. Now what we have to do? We have to simplify the given function. How we can simplify? Please observe 2 pi by 3. Pi by 3 is 60 degree. 60 degree into 2, 120 degree. 120 degree lies in second quadrant. So I have to write in terms of second quadrant. How I can write? That is pi minus pi by 3. Please take LCM, you will get a 2 pi by 3 only. Please observe 3 pi minus pi divided by 3 is equal to 2 pi by 3. Now sine of pi minus pi by 3, how I can write? This lies in a second quadrant. In a second quadrant, sine trigonometric function is positive. Therefore, sine of pi minus pi by 3 can be written as sine pi by 3. Is this clear? Okay, sine pi by 3. Now what will happen, students? Sine inverse of sine x angle, that is equal to x when x belongs to closed interval minus pi by 2 comma pi by 2. Is that possible to write is equal to x here? Yes, it is possible. How? pi by 3, clearly pi by 3 belongs to closed interval minus pi by 2 comma pi by 2. Therefore, the value of this function or the principal value of this particular function is pi by 3, which is clearly belongs to principal value of sine inverse, that is minus pi by 2 comma pi by 2. This is the way of solving. Now we'll move on to the second question, students. Second question is, find the value of tan inverse of tan 3 pi by 4. According to the property, tan inverse of tan x will be there. I can write directly x. X belongs to its principal value branch. Which inverse trigonometric function? Tan inverse. Its principal value branch is open interval minus pi by 2 comma pi by 2. Please observe 3 pi by 4. Pi by 4 is 45 degree. 45 degree into 3 will be 135 degree. Whether 135 degree is belongs to open interval minus pi by 2 comma pi by 2, which is does not belong to, isn't it? So that how we can solve this particular function. 135 degree, 3 pi by 4, which is in a second quadrant. How we can write in a second quadrant? Please observe. So that is pi minus pi by 4, 180 minus 45 degree, isn't it? So if you take the LCM, you will get the value 3 pi by 4 only. So that is 4 pi minus pi whole divided by 4 is equal to what? 3 pi by 4. Now how I can write tan of pi minus pi by 4? Tan trigonometric function in a second quadrant, positive or negative? Which is negative. How I can write now? Tan of pi minus pi by 4, tan trigonometric function in a second quadrant, it is negative. So therefore minus tan pi by 4. Okay. So how we can write in a next step? Please observe. Minus I wrote as it is. Tan pi by 4 value is 1. Now tan inverse of minus 1. Once again I am going to use one of the property. Which one is that property? Tan inverse of minus x is equal to minus tan inverse x. Tan inverse of minus x is equal to minus tan inverse x, where x belongs to r here. So minus tan inverse of 1. So I'll write equal to minus as it is. Tan inverse of 1 can be replaced with pi by 4. So that clearly minus pi by 4 minus 45 degree, which is belongs to open interval minus pi by 2 comma pi by 2. Please observe in this problem. Initially I cannot write 3 pi by 4, which is does not belong to open interval minus pi by 2 comma pi by 2. Then later on I have simplified using the trigonometry and inverse trigonometric function results. Then I got the final answer. Principal value is minus pi by 4, which is belongs to the value of this particular function is minus pi by 4, which is belongs to minus open interval minus pi by 2 comma pi by 2. Okay. Now we'll move on to the third question, students. Third question is in terms of cos inverse, that is find the value of cos inverse of cos 7 pi by 6. Now is that possible to write the direct answer is equal to 7 pi by 6? Please observe. Pi by 6 is equal to 30 degree or 60 degree. Pi by 6 is 30 degree. 30 into 7. 7 3 is 210 degree. Whether 210 degree, which is belong to closed interval 0 comma pi, students? No. Which is does not belong to closed interval 0 comma pi. Therefore, we have to use the sum of the steps based on the inverse trigonometry function and trigonometry. How we can write, students? Please observe 210 degree, which is clearly lies in a third quadrant. How I can write in the third quadrant 7 pi by 6, that is pi plus pi by 6. Please observe. If you take a LCM, students, 6 is the LCM, then 6 pi plus pi will be 7 pi by 6. Okay. Now pi plus pi by 6, 180 plus, isn't it? So which lies in a third quadrant. third quadrant cos trigonometric function is negative. Please remember this point. In a third quadrant, cos trigonometric function is negative. Therefore, cos inverse of minus cos pi by 6. Okay. Now, what will happen here, students? Cos inverse of minus I will write as it is. I cannot apply here any inverse trigonometric function property directly, so that minus I will write as it is. Cos pi by 6 value will be root 3 by 2. Now here I can apply the inverse trigonometric function property. Which property? That is cos inverse of minus x is equal to pi minus cos inverse x. Is this clear? Cos inverse of minus x is equal to pi minus cos inverse x. Now how I can write this result? That is pi minus cos inverse of root 3 by 2. So in a next step, pi minus cos inverse of root 3 by 2 can be written as pi by 6. Please take a LCM, students, so that LCM is 6. Then 6 pi minus pi will be 5 pi by 6. Pi by 6 is 30 degree. 30 into 5 will be, students, 5 3 is 15. So that is 150 degree. Clearly 150 degree or a 5 pi by 6, which is belongs to closed interval 0 comma pi. So that for this particular function, answer is 5 pi by 6, which is clearly belongs to closed interval 0 comma pi. Please observe here, students. Here I have applied the property. One property is cos inverse of minus x is equal to pi minus cos inverse x. Okay. Next problem, fourth problem says, find the value of cos inverse of cos 13 pi by 6. Okay. Cos inverse of cos 13 pi by 6. Is that possible to write directly? 13 pi by 6 is the answer? No. Which is 13 pi by 6 does not belong to closed interval 0 comma pi. Therefore, so first I will write the given function. Then 13 pi by 6 can be written as, students, this 13 pi by 6, this will cross more than 360 degree. So which lies after one complete rotation, once again it will stop in the first quadrant only. So that 13 pi by 6 can be written as 2 pi plus pi by 6. Okay. So 2 pi. So 2 pi plus pi by 6, it means which lies in first quadrant. In a first quadrant, please remember, in a first quadrant, all the 6 trigonometric functions are positive. Cos inverse of cos pi by 6 is equal to what? Cos inverse of cos x can be written as x. So that cos inverse of cos pi by 6 is equal to pi by 6 only. Clearly pi by 6, which is belongs to closed interval 0 comma pi. Okay. Please observe in this problem, students, directly I cannot write the answer as 13 pi by 6 because 13 pi by 6, which does not belong to closed interval 0 comma pi. So that we have simplified in this method. So 13 pi by 6 can be write it as 2 pi plus pi by 6. This lies in a first quadrant after one complete rotation, isn't it? So in a first quadrant, all the trigonometric functions are positive. Therefore, cos of 2 pi plus pi by 6 is equal to cos pi by 6. Then we have applied the inverse trigonometric function property. That is, cos inverse of cos x is equal to x. So cos inverse of cos pi by 6 can be written as pi by 6. Clearly pi by 6, which is belongs to closed interval 0 comma pi. Now we'll move on to the fifth problem, students. Fifth problem is, find the value of tan inverse of tan 7 pi by 6. Tan inverse of tan 7 pi by 6. Please observe here, students, tan inverse of tan x is equal to x. Is that possible to write? 7 pi by 6 is the answer for this particular question? No. Pi by 6 is 30 degree. 30 into 7, 210 degree. 210 degree, which does not belong to open interval minus pi by 2 comma pi by 2. So therefore we have to simplify this function using properties of inverse trigonometric functions. Now 7 pi by 6, how I can write? This lies in a third quadrant, students. How I can write? 7 pi by 6 can be expressed as pi plus pi by 6, 180 plus some angle. So in a third quadrant, tan trigonometric function is positive or negative? Yes, it is positive. So that is tan of pi plus pi by 6 is equal to tan pi by 6. Now I can use the property, students. Tan inverse of minus x is equal to minus tan inverse x. Is that necessary to use that property here? No need, isn't it? So tan inverse of tan x property I can use. Please remember, tan inverse of tan x property I can use. What is that? X. So that is tan inverse of tan x is equal to x. If we get a negative here, tan of minus pi by 6, then I have to use the property minus tan inverse x. Just we have recollected once again the property. Okay. So pi by 6, which is clearly belongs to open interval minus pi by 2 comma pi by 2. Therefore the value of tan inverse of tan 7 pi by 6, its answer is pi by 6, which is belongs to open interval minus pi by 2 comma pi by 2. Now we'll move on to the next problem, students. Sixth problem. Find the value of sine inverse of sine 3 pi by 5. Please observe, pi by 5, that is equal to 36 degree. Now 3 pi by 5, that is equal to 108 degree. Why I am repeating in terms of degree? Easily you can identify it lies in a which quadrant, whether it is belongs to the principal value branch or not, or else you can remember in a radian only. Now sine inverse of sine 3 pi by 5 is equal to 3 pi by 5 if I write, which does not belong to closed interval minus pi by 2 comma pi by 2. Therefore I have to simplify this function. Okay, so 3 pi by 5 clearly lies in a second quadrant. How I can write in terms of second quadrant? So that is pi minus 2 pi by 5. Please observe, you can cross check this angle. How? That taking a LCM, 5 pi minus 2 pi is equal to 3 pi by 5. LCM, it is 5. Okay. So now sine of pi minus 2 pi by 5, which lies in a second quadrant. In a second quadrant, sine trigonometric function is positive. Therefore sine of pi minus 2 pi by 5 can be written as sine 2 pi by 5. Please observe, sine of pi minus 2 pi by 5. This lies in a second quadrant. In a second quadrant, sine trigonometric function is positive. Therefore, sine of pi minus 2 pi by 5 is equal to sine 2 pi by 5. Now I can use the property here. That is, property is sine inverse of sine x can be written as ex. Now sine inverse of sine 2 pi by 5 can be written as 2 pi by 5. Clearly 2 pi by 5, which belongs to closed interval minus pi by 2 comma pi by 2. Please observe in this problem, very important, sine inverse of sine 3 pi by 5. Directly I cannot write 3 pi by 5. Why? Because 3 pi by 5 does not belong to closed interval minus pi by 2 comma pi by 2. Because of that reason, we have simplified this function and we got the final answer is 2 pi by 5 belongs to closed interval minus pi by 2 comma pi by 2. Now we'll move on to the next problem, students. Next problem is prove that problem. Prove that 9 pi by 8 minus 9 by 4 sine inverse 1 by 3 is equal to 9 by 4 sine inverse 2 root 2 divided by 3. So obviously prove that problem, students. We can consider left hand side expression or a right hand side expression. What I will do here, students, in this particular problem, I'll consider the left hand side expression. Left hand side expression is 9 pi by 8 minus 9 by 4 sine inverse 1 by 3. Now please observe this result. Is that possible to take any common term from this expression? We'll verify. Is that possible to take sine inverse of 1 by 3? No, it is impossible to take. Is that possible to take out pi angle? No. Is that possible to take 9 by 8? No. Is that possible to take a common term as a 9 by 4? Yes, it is possible to take. How we can take, students? Please observe. If I take 9 by 4, then remaining will be pi by 2 minus sine inverse 1 by 3. Please observe, students, please observe this bracket, what expression we have that can be written as, I'll tell you that property is sine inverse x plus cos inverse x is equal to pi by 2, isn't it? Sine inverse x plus cos inverse x is equal to pi by 2. So how I can write pi by 2 minus sine inverse x? Left with cos inverse x. Therefore, in the same way, pi by 2 minus sine inverse 1 by 3 can be replaced with cos inverse x, but x with we have the value 1 by 3. So 9 by 4 cos inverse 1 by 3. Now what I am going to do, I'll give the expression as a 1, but in the right hand side I should get the answer in terms of sine inverse. Okay, now what I have to do, cos inverse of 1 by 3 we have to convert in terms of sine inverse trigonometric function. What I will do here, students, please observe, cos inverse of 1 by 3, I'll name it as theta. Then cos theta can be written as 1 by 3. Cos trigonometric function, how we can define? Cos theta is equal to adjacent side by hypotenuse. Cos theta is equal to adjacent side by hypotenuse. In a right angle triangle, students, adjacent side by hypotenuse I can mention. So please observe, adjacent side is 1, hypotenuse is 3. So we have to find the opposite side of a right angle triangle. How we can find out? Using Pythagoras theorem, isn't it? So that so 3 square minus 1 square will be left out with the opposite side. So that will be square root of 8. Students, please remember, square root of 8, it can be written as square root of 4 into 2. Square root of 4 into 2 can be written as 2 square root of 2. I'll repeat, square root of 8 can be written as square root of 4 into 2. Square root of 4 into square root of 2 can be written as 2 square root of 2. So this square root of 8 can be replaced with 2 square root of 2. So how we can write, we can replace the expression 1, or sine theta can be written as opposite side by hypotenuse. Opposite side is 2 root 2 divided by hypotenuse is 3. Therefore theta can be replaced with sine inverse 2 root 2 divided by 3. Now expression 1 I will take, students. Expression 1 is 9 by 4. Cos inverse of 1 by 3 can be replaced with theta, isn't it? So expression 1 is remaining 9 by 4 into theta. So expression 1 can be replaced with 9 by 4 into theta. Theta can be replaced with in terms of sine inverse function, that is sine inverse 2 root 2 divided by 3. Clearly we got the right hand side expression, isn't it? Okay, please observe, in this problem we have considered the left hand side expression. Then I have used one inverse trigonometric function property. That property is sine inverse x plus cos inverse x is equal to pi by 2. I have used that result here. Then cos inverse of 1 by 3 I have converted in terms of sine inverse. Okay, sine trigonometric function can be written as opposite side by hypotenuse. Opposite side is square root of 8. Square root of 8 can be written as 2 square root of 2. Okay. Therefore, sin theta is equal to 2 square root of 2 divided by 3, and theta can be written as sin inverse of 2 root 2 divided by 3. Then this theta we have substituted in a expression 1. So when we have substituted expression 1, we got 9 by 4 sin inverse 2 root 2 divided by 3. Clearly this is the right hand side expression. Therefore, LHS is equal to RHS, hence the proof. Okay. Now we'll move on to the next result, students. Next result is find the value of tan inverse of x by y minus tan inverse of x minus y divided by x plus y. Please observe this question. I hope you can remember that property in terms of tan inverse. Which property, students? Tan inverse x minus tan inverse y, isn't it? So I'll repeat that result. Tan inverse x minus tan inverse y is equal to tan inverse of x minus y divided by 1 plus x into y. Okay. So I'll consider the given function. Then I am going to apply the tan inverse x minus tan inverse y result. So what is the result, students? Tan inverse of x minus y divided by 1 plus x into y. Please, what is x here? That is total x by y minus x minus y divided by x plus y whole divided by 1 plus x by y into x minus y divided by x plus y. Now what I have to do, students? I have to take the LCM. See, look at here. In the numerator, which term will be the LCM here? That LCM is y into x plus y. It is the LCM. So what I have to do? For this x, I have to multiply with x plus y. So x into x square, plus x into y, xy. Then for the minus of x minus y, I am going to multiply with y. So what will happen? Minus xy, minus into minus plus y into y plus y square. Now we'll verify in the denominator. We'll take once again LCM. LCM is what? Y into x plus y. What I have to do? Y into x plus y, it is going to multiply it with 1. So what will happen, students? Yx plus y square, isn't it? Yx plus y square plus x into x square, x into minus y, minus xy. Please observe here, in a numerator denominator term, in a denominator term will get cancelled. Then remaining will be, and please observe, plus xy minus xy will get cancelled, commutative law in multiplication. And here plus yx minus xy get cancelled, and remaining will be, students, remaining term is tan inverse of x square plus y square, denominator got cancelled, whole divided by y square plus x square. What will happen? Once again terms will get cancelled. Remaining will be tan inverse of 1, isn't it? Remaining will be tan inverse of 1. Tan inverse of 1 can be written as pi by 4. So therefore the answer for the given question, tan inverse of x by y minus tan inverse of x minus y divided by x plus y, its value is pi by 4. Now we'll move on to the next question. Ninth question is, if sin inverse of 1 minus x minus 2 sin inverse x is equal to pi by 2, then find the value of x. So we have to find the value of x here. So what I will do, I'll consider the given data. That given data is sin inverse of 1 by x, sin inverse of 1 minus x minus 2 sin inverse x is equal to pi by 2. Now how I can simplify this result? Please observe. I am going to take here one of the substitution. Substitution is for the sine inverse x, I'll consider as theta. Okay, for the sine inverse x, I'll consider as theta, and x can be written as sine theta. Okay, please don't rearrange this one. Don't write first x is equal to sine theta. Okay, so first you should write from the given data you have taken sine inverse x is equal to theta. From this expression, so implies from this expression I am going to write x is equal to sine theta. Now I'll write it as sine inverse of 1 minus x minus 2 theta. In sine inverse x can be replaced with theta is equal to pi by 2. Now what I will do, students, this minus 2 theta I will shift to the right hand side. So that will become pi by 2 plus 2 theta. Once again I am going to apply sine trigonometric function to both the sides. So what will happen, students? So that result will be 1 minus x is equal to sine of pi by 2 plus 2 theta. How we got 1 minus x? I told here we are going to apply sine trigonometric function to both the sides. So then will be sine of sine inverse of 1 minus x will be 1 minus x. Then sine of pi by 2 plus 2 theta. Please observe here sine of pi by 2 plus 2 theta. Pi by 2 plus, it lies in a second quadrant. In a second quadrant, sine trigonometric function is positive. But in the allied angle format, so when angle which lies in a y coordinate, student, sine trigonometric function changes to cos. So that sine of pi by 2 plus 2 theta can be written as cos 2 theta. Is this clear? Sine of pi by 2 plus 2 theta can be written as cos 2 theta. Once again I'll repeat, pi by 2 plus 2 theta which lies in a second quadrant. In a second quadrant, sine trigonometric function is positive. But when in allied angle format, when angle lies in a y coordinate, pi by 2 lies in a y coordinate, so by that time sine trigonometric function changes to cos. So that cos 2 theta. So now 1 minus x is equal to cos 2 theta is the left out expression, isn't it? So what will happen, students? 1 minus x is equal to cos 2 theta. Please observe, cos 2 theta can be replaced with 1 minus 2 sine square theta. You may get a confusion. Cos 2 theta will have the total 4 formulae. Why I took only here in terms of sine? Because I gave the substitution in terms of sine, isn't it? X can be replaced with the sine theta I wrote. That was my substitution. So that cos 2 theta I have replaced with 1 minus 2 sine square theta. 1 minus x. Now what I did here, students, 1 minus 2 sine theta can be replaced with x, isn't it? Initially we have taken sine theta is equal to x, sine square theta is equal to x square. So that entire 1 minus 2x square I have shifted to the left hand side. So that will become 1 minus x as it is minus 1 plus 2x square is equal to 0. Now plus 1 minus 1 get cancelled. Remaining will be 2x square minus x is equal to 0. From this expression, students, I can take out x common. So x into 2x minus 1 is equal to 0. Now a into b is equal to 0. It means either a is equal to 0 or a b is equal to 0. Therefore, I'll get two solutions here. X is equal to 0 or x is equal to 1 by 2. Yes, students, I got two solutions, but my work is to verify whether two solutions will satisfy the given question or not. X is equal to 0. Please substitute here. Then will be sine inverse of 1 minus 2 sine inverse of 0. Sine inverse of 0 will be 0. So that is sine inverse 1 minus entire term is going to be 0. Sine inverse 1 is equal to pi by 2. So left hand side we got pi by 2. Right hand side expression is pi by 2. LHS is equal to RHS. Therefore x is equal to 0. It is the solution for the given question. Now we are going to verify with x is equal to 1 by 2. Then sine inverse of 1 minus 1 by 2. It remaining is sine inverse 1 by 2 minus 2 sine inverse 1 by 2. Okay. So sine inverse 1 by 2 can be written as pi by 6 minus 2 into pi by 6. So pi by 6 minus 2 1s are 2 3s are, then will be pi by 6 minus pi by 3, which not equal to pi by 2. Therefore, x is equal to 1 by 2. It is not a solution for a given question. So how I can conclude this result? X is equal to 1 by 2 does not satisfy the given equation. Therefore, solution is x is equal to 0 is the solution of the given equation. Okay, please observe in this problem, students, initially we have considered the given equation, then we have substituted sine inverse x can be replaced with theta, therefore x is equal to sine theta. Then we have replaced entire expression. Okay, then at the finally we got 1 minus x is equal to cos 2 theta. Cos 2 theta we have replaced with 1 minus 2 sine square theta. Then sine square theta we have replaced with x square. Then we have solved this expression. At the finally we got x into 2x minus 1 is equal to 0. X is equal to 0 or 2x minus 1 is equal to 0. 2x minus 1 is equal to 0 implies 2x is equal to 1. X is equal to 1 by 2. But x is equal to 1 by 2 does not satisfy the given equation. Therefore, conclusion is x is equal to 0 is the solution of the given equation. While writing the answer, you should mention this step. Then only you can conclude as x is equal to 0 is the solution of the given equation. Okay. Now we'll move on to the next problem. That is a multiple choice question. The domain of sine inverse 2x is. Till here, students, in a beginning in a table we got a domain for all the inverse trigonometric function with the angle x. But here sine inverse 2x is there, isn't it? Now how we can simplify this question? They gave the total 4 options here. First option is closed interval 0, 1. Second option is closed interval minus 1, 1. Third option is closed interval minus 2, 2. Fourth option is closed interval minus 1 by 2, 1 by 2. Now how we can solve this result? How we can find out the domain? What is the domain for the inverse trigonometric function sine inverse x? Its domain is closed interval minus 1, 1. Okay. Now what I will do, students, sine inverse 2x I will replace with theta. Then 2x can be written as sine theta. Please observe, sine inverse 2x I have replaced with theta. Then 2x can be written as sine theta. Now sine theta which lies in between, where to where? That is minus 1 to 1. Sine theta lies minus 1 less than or equal to sine theta less than or equal to 1. It is the domain of a sine inverse function, isn't it? Now sine theta can be replaced with 2x. Okay, sine theta can be replaced with 2x. Now at the finally I need an answer is in terms of x. Okay, to get the answer in terms of x, what I have to do? Throughout the expression I have to divide with 2 positive number. So inequality will remain same, isn't it? So that is minus 1 by 2 less than or equal to x less than or equal to 1 by 2. I hope now you can guess the answer. X, that is the domain. X will take the value which is in between, including minus 1 by 2, 1 by 2 and in between minus 1 by 2, 1 by 2. So therefore right answer is, that is option D, that is closed interval minus pi by 2, 1 by 2. I'll give the hint, students. Here that question may be with sine inverse of minus x square or else with the cos inverse of 1 minus x square. We are going to follow the same result. Okay, but you should know the 6 inverse trigonometric functions domain before going to solve this type of question. Okay, if it is sine inverse of minus x square, what will happen, students? X is the same. Okay, minus 1 less than or equal to x less than or equal to, and then you are going to multiply with the negative so that you will get the answer. Okay, now we'll move on to the next question. Next 11th question is, If sine inverse x plus sine inverse y is equal to pi by 2, then the value of cos inverse x plus cos inverse y is, okay, please read the question properly. If sine inverse x plus sine inverse y is equal to pi by 2, this is the given data, then the value of cos inverse x plus cos inverse y is, okay, given option is pi by 2, pi, 0, 2 pi by 3. How we can solve the question? First we'll consider the given data. Sin inverse x plus sin inverse y is equal to pi by 2. Okay, and we have learned the property in the inverse trigonometric function. Which property? Sum of the inverse trigonometric function, that can be written as sin inverse x plus cos inverse x is equal to pi by 2. This result from the inverse trigonometric functions, we have proved this result also, so that with lots of confidence I wrote, we know that sin inverse x plus cos inverse x is equal to pi by 2. Now we are going to equate the result. Sin inverse x plus sin inverse y is equal to pi by 2, and pi by 2 is equal to sin inverse x plus cos inverse x. What will happen, students, here? Sin inverse x get cancelled. Remaining will be sin inverse y is equal to cos inverse x. Now cos inverse x can be replaced with the sin inverse y. Please observe, cos inverse x can be replaced with the sin inverse y. Then sin inverse y plus cos inverse y is, we know that sin inverse y plus cos inverse y is what? That is equal to pi by 2. I am going to give another method also, students, to solve this question. Sin inverse x plus sin inverse y is equal to pi by 2, and the sin inverse x can be replaced with pi by 2 minus cos inverse x, plus sin inverse y can be replaced with pi by 2 minus cos inverse y is equal to pi by 2. If you simplify, you will get the answer pi by 2 only. That is also the another method to solve this question. Okay, so here right answer is option A, that is equal to pi by 2 is the correct answer for the 11th question. By this we have come to end of this chapter, students. Okay, before going to conclude this chapter of inverse trigonometric functions, just will recapitulate what we learnt in inverse trigonometric functions. In the beginning, to define an inverse, function should be bijective. I mean, function should be 1, 1 and onto. To define a 1, 1 and onto, we have restricted domain and range. So at finally, we have defined all the 6 inverse trigonometric functions. We got one of the table, that's inverse trigonometric function, way to way, domain to range. That range column will be principal value branch also. That is the main point or a main content of a inverse trigonometric functions, that is domain and range or a principal value branch. Then we have solved some of the properties of inverse trigonometric functions, and we have solved the results also. Later we have solved problems based on properties of inverse trigonometric functions. Then we have discussed how we can convert functions into simplest form. Then we have also find some special type of functions, how we can write the principal value branch for some special type of functions. By this we have completed the chapter inverse trigonometric functions. Thank you.